So one thing that is very important to be able to do is what we call these exact values, and that is the ability to know what the sine, the cosine, and the tangent of 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees are. And we've got to be able to know these and be able to use them without a calculator. So let's start off with the following triangle. It's going to be down here. It's going to be a right angle triangle, okay, with the following dimensions. We're going to have an angle in here of 60 degrees, which means that this angle in here would have to be 30 degrees, okay? And to keep this to scale, if this is 1 unit, then this would be the square root of 3, and this would be 2 units long, okay? So this is to scale. If you just trust that, we'll be able to fill in this table. So let's start off by looking at what the sine of 30 degrees is. Okay, well, that is going to be equal to my opposite over my hypotenuse for sine. Okay, so looking at my 30-degree angle, my opposite is 1 and my hypotenuse is 2. So the sine of 30 degrees is just a half. So I can put that in there. If we have a look at the cosine of 30 degrees, that is going to be the adjacent divided by my hypotenuse. So we're going to be looking at the square root of 3 divided by 2 here. So we can pop that one in. And finally, for the tan of 30 degrees, we are looking at our opposite over our adjacent. So our opposite being 1 and our adjacent being the square root of 3. So we can pop that one in down the bottom here. Now, if we move on to our 60-degree angle, let's have a look at what the sine of 60 degrees is. So our opposite, our adjacent, and our hypotenuse are all changing now. Okay, so the sine of 60, the opposite over the hypotenuse from our 60-degree angle, so the opposite being the square root of 3, and our hypotenuse being 2. So we can pop that one into there. If we have a look at the cosine of 60 degrees, we're looking at the adjacent over the hypotenuse, so that is going to be our 1 over 2, so we can pop that one into there. And finally, our tan of 60 degrees, that one there is equal to our opposite over our adjacent, okay, which is our square root of 3 over 1, which is just the square root of 3, so we can pop that one into there. Next up, we're going to clear this and we're going to look at our 45-degree angle. So for our 45-degree angle, we're going to use a different triangle, okay? Again, it's still going to be a right angle triangle, except we're going to be looking at angles inside here of 45 degrees, okay? And if we've got a 1 here and a 1 here, then this would have to be, by Pythagoras, the square root of 2 long to keep this drawing to scale. Now, let's say that I want to work out what the sine of 45 degrees is. Okay, well, I do my opposite over my hypotenuse, so I'm looking at 1 over the square root of 2, and I can pop that into there like that. Now, if I want the cosine of 45 degrees, I'm looking at my adjacent over my hypotenuse. Okay, so again, that will also be 1 over the square root of 2, so we can pop that one into there. And finally, the tangent of 45 degrees. That's going to be our opposite, which is 1 over our adjacent, which is 1. So we just get 1 for that. So the tan of 45 here is equal to 1. Finally, we'll clear this again and we'll look at 0 degrees and 90 degrees using the unit circle. So if we draw a unit circle down here into the corner, okay, and we're asked to find what the sine of 0 degrees is. Well, remember how we do that? We measure our 0-degree angle, which is this angle out here, and we ask ourselves how far have we gone up the y-axis. And in this case, we've not climbed anywhere up the y-axis. So sine of 0 would just be equal to 0, so we can pop that into there. Cosine, however, we draw the same angle and we ask ourselves how far have we climbed along our x-axis, and in this case we have moved 1 unit along our x-axis. We've gone all the way to the edge. So the cosine of 0 degrees, that is equal to 1. Now if I want the tangent of 0 degrees, remember that the tangent is equal to sine divided by cosine. So I do the sine of 0 degrees divided by the cosine of 0 degrees. So the sine of 0 degrees, we know that that's 0, and the cosine of 0 degrees is 1. So my answer here is 0. So I see that the tangent of 0 degrees is 0. Next up, we'll have a look at our 90-degree angles. So we'll just erase this here. And this time we're going to use the blue line, which goes up a 90-degree angle. So we're looking at this line here. So we'll start off with the sine of 90 degrees, again asking ourselves how far have we gone up the y-axis? Well, we have gone 1 unit up the y-axis here. So we know that the sine of 90 is equal to 1. The cosine of 90, asking ourselves how far have we moved along the x-axis with this blue line? Well, we haven't gone anywhere, so the cosine of 90 is equal to 0, so we can pop that into there like that. And remember, the tangent of 90 degrees, once again, that is equal to our sine over our cosine, so that identity, which is nice and handy for us. And we know that the sine of 90 degrees is 1, and the cosine of 90 degrees is 0. And we experience a big issue when we have to divide by 0. We cannot do that. We can't divide anything by 0. So the answer to this one would be that this is actually undefined. There is no answer for the tangent of 90 degrees. So now we've fully filled in this exact values table, and this is something that you'll need to memorize. You have to come up with a way to remember these, okay? And there, if you have a look at it, there are a few patterns here and there, okay? But this is something that you'll need to know and something that you'll be able to do without a calculator. What we'll look at now is if we start to move ourselves out of the first quadrant. So what if we start to adventure into, let's say 130 degrees or angles out here, okay? So let's draw ourselves a unit circle again, okay, and we'll do a couple of examples. Let's say that I'm asked to find what the sine of 135 degrees is without a calculator. Well, I know that that 135 degree angle is actually this angle that's coming out here, okay, and I'm actually 45 degrees above my x-axis there. Well, if I was to measure the sine of that angle, I need to come across to my y-axis, remember. And what angle can I also draw which is going to give me the same y value as what I'm getting there? Well, it would have to be this angle out this way, which is also 45 degrees. So we're looking at that symmetry in the y-axis that we spoke about. Okay, so I know that sine of 135 degrees, well, that is equal to the sine of 45 degrees. And using my exact values, okay, I know that that is equal to 1 over the square root of 2. So for one more example, let's say that we need to find what the cosine of 210 degrees is. Okay, well that angle, we'll draw it in a red pen again, that is actually 30 degrees below this 180 degree line. So if that's 180 degrees, this here would be 210 degrees. So this angle in here is 30 degrees. And if I was to measure the cosine of that, remember, I come up to my x-axis. Okay, well with reference to my my angle in the first quadrant, if I was to come 30 degrees out here, so let's say that that is 30 degrees, and I measure to my x-axis, I see a very similar relationship with what I see here and here. In fact, they're exactly positive and negative versions of each other. Remember, this one over here is going to be the negative version, and this one over here is going to be the positive version. So the cosine of 210 degrees is going to be the negative version of whatever the cosine of 30 degrees is. Okay, and I know what the cosine of 30 degrees is. It's the square root of 3 over 2. We just worked that out in our table. So the answer to this question would be negative the square root of 3 over 2, and that would be the value that I'm measuring there. Finally, we'll do one with the tangent, where we will look at the tan of 120 degrees. Okay, so in the red pen, we will draw our angle, our 120 degree angle, and that is this angle here. In fact, we've actually come up 60 degrees off of our x-axis, okay, because this is 90 here, so this would be our 120 degree angle there. Now, if we have a look at our ASTC, okay, we see that tangent is positive here and it's positive in this quadrant. Our angle of 120 degrees, we're going to see that tangent is going to be negative, okay? So if we compare that to our 60 degree angle that we could draw out in this side, we are going to see over here we're positive, whereas over here we are negative. So we are going to have the negative version of the tan of 60 degrees, okay? And I know that the tan of 60 degrees is the square root of 3, so the answer to this question would be negative the square root of 3.